All right, students, in this video, we are going to discuss the surface area of a cone. All right, as far as the concept of cone is concerned, I must tell you one thing in the starting that there is something which is right circular cone, and on the other hand, there is simply a cone. You can also call it slant cone. There's a difference between these two. First, you have to understand. When you talk about right circular cone, this is example of right circular cone, right? Now, what is this? A cone has so many parts. Number one, the base of the cone, like it's that cone in which you eat the ice cream. A perfect example. Without ice cream, the cone is hollow, and when the ice cream is there inside the cone, you can call it a solid cone. But then the ice cream is not protruding outside from the circle, it's on the level of the circle. Then you can say it's a solid cone. All right. Uh, what are the different parameters or characteristics of a cone, guys? This side of the cone, this length of the cone is, you can say this length is, or this length is the outer length, and the inclined length is known as slant height. SLANT, slant height. All right, guys, this is normally represented by L. Obviously its unit is meter or centimeter. And this height which join the vertex of the cone, or you call it apex of the cone, whatever it is, or tip of the cone, with the center of the base circle. This is the center of the base circle I present by O. So this height is known as H. This is the vertical height of the cone. I call it vertical height H, and slant height is L. Well, guys, this is the radius of the cone. The radius of the base circle is the radius of the cone. If diameter is given, simply divide by 2, you get the radius. All right. So when there is a slant cone, I'm sorry, this is a right circular cone because this H, the height of the cone is basically making 90 degrees with the radius vector, or you can say plane of the circle. There may be a cone like this. This is a bottom circle, and the cone is like this. This is also a cone, but it's not a right circular cone. This is an example of a slant cone. All right, guys, I rub this for a minute, and then we see how we can calculate the surface area of the cone. Let's say the cone is hollow. When the cone is hollow, there's no ice cream in this, and the surface of the ice cream on the top of this circle is not generated. All right. So this surface area will not be there in case of hollow cone. Only this curved surface area, will be there. In order to see how can we calculate quickly the surface area of the cone, let's take the help of GeoGebra software. Engineers have created it, and we can very well understand how we can calculate the surface area of a right circular cone, or simply a cone. When we just say cone, it means a right circular cone. All right, guys. So let's go here. I share the screen. Mm, I share with this. All right, guys. So I'm gonna, you see, this is something I want to again explain. This is H. Or when you hit the cone, when you hit the softy, you hit like this. The circle is upwards, and this is the height, the perpendicular distance height. This is the slant height. They have called it S, but we'll call it L. And this is the radius of the circle, right? So if you decrease the height, cone becomes like this. When you increase the height, when you decrease the radius, you see cone becomes like this. When you increase the radius, it becomes like this. All right, guys. So now I'm going to take you how can we calculate the surface area of the cone. Guys, you see that it's a beautiful illustration. This is a circle, the surface area, like different, it's like latitudes and longitudes. So you see that this is a cone. All right, I can drag it down. All right, and then I can drag it up. Right, it's really interesting. And if I just drag it down, you see, I get this thing. This is a plane. All right. If I just drag it up, well, it becomes a cone. So basically, it becomes a cone. All right, guys. So you just see now. How can I calculate the? You see, the complete area of this cone is, can we say, the sum of these small triangles? Like the tip of the triangle is here. Let's take this side, then this side, and this side. So if you just calculate the area of one triangle, and if you multiply by area of all the triangles, we'll get the complete uh, the circular area or the area of the cone. Am I right, guys? All right. Now we need to understand few things. You see, this cone is having this circle made by the thick dark line, right? If r is the radius of this circle, if r is the radius, the circumference or the length of this circle will be 2 pi r. Am I right? Right. Now, what will be the area of this individual triangle? Now, area of triangle is half into base into height. Now, I take this triangle very, very small. Now, actually, this is a circular length, if you see. This circular thing, I take this triangle very small. So I can say, what is the area of this triangle is half into base into height. So what is the height? Now, height is this slant height only, which I have taken L. You see, all these lines, this, all these lines are slant height. If you see, they're the same. They are same equal distance from the apex to this circle. You know, so these are all slant heights L. Now, area of this triangle will be half into base. Base is, let's say this, I take this base as B1, and this base all are maybe B2 or B3. If they are different areas, if they are same areas, all are B1, 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 right? As you like, you can take it. So area of this triangle is half into this base B1 into height. What is height? Height is this side. Now you might wonder that normally the height of the triangle is, you see, starting from here and going straight down here. But you see, if this triangle is very small, these sides try to come near, and you can say the height is same as these sides, right? Well, start from here and here, whether you draw this line or you draw this line, all these lines are same distance. So half into base into height is the area of one triangle. And then based upon this, we can find out the, area of all the triangles. And area of all the triangles will be equal to surface area of this cone. Let's see how do we do it. So it's like no shear here and shear. All right, guys. So you see, I've showed you how I successfully, divide this cone into so many triangles, and all the triangles are around this circle, and the radius and the circumference of the circle is 2 pi r. So what will be the area of individual triangle? Individual triangle would be half into base into height. Now, guys, that base we are taken at as B or B1 or whatever it is, and if they are all same size triangles, so you see this side, this side, because all the three are inclined heights, they are L. So it's like half into bases we have taken B into height of the triangle we have taken, it's L. If you have seen there, if you remember, half into base into L. All right, this is the area of first triangle. Now total area of the cone will be sum of all the small triangles. So let us imagine there are n triangles. So it will be 1 by 2 into this B, because base, you have seen triangles, you have taken same base, same size triangles, into L. This is the area of one triangle into all n triangles, you can say into n, or you can say this is equal to half into, let's say, first base is B into L, right, plus half into B into L, plus half into b into L plus how many times? N times. We will take again half into b into L. You see guys, I can take half into L common, and what you get, this b plus b plus b, how many times? N times b, am I right? So this is equal to half into L into uh, b into n times. Now you just see this, this was a triangle there, this was the base b. Now this base, I'm assuming all the triangles are how many triangles? N triangles. Here also one triangle, here also one triangle, here also one triangle. All are having base b. Now this b is coming how many times? N times. So what is n into b? If I join all the b, 1b, then 2b, 3b, 4b, 5, 6, 7, 8, 9, 10, n b's, this will come as the circumference of this circle. And we already know circumference of the circle is 2 pi r, because all these triangles are over this circle r. So I can say this n into b is equal to 2 pi r. Alright guys, this is 2 pi r. And you see guys, 2 cancels with 2. Ultimately what I get is pi r l. That's good. Unit square. So the surface area of a hollow triangle is pi r l. Now guys, very quickly we can do the surface area of a solid triangle also. In case of a solid triangle, the surface, simply the area of the bottom circle will also come. So total surface area would be equal to pi RL plus pi